Alright, today we're going to start scientific notation, and there is a toolkit entry in Chapter 10 on scientific notation. So if you want to add any of these notes to your toolkit, you might want to hit pause and get it out. Scientific notation is a way of writing a very large or a very small number in a short way. So we're going to be taking a look at very large numbers or very short numbers today, and we're going to be writing them in a short way. So let's take a look at this first example. And we're going to be writing the numbers first in standard form. So we have 386 billion. And we're going to write it in a short way called scientific notation. And we want to write it so that it is a number between 1 and 10. Well, actually less than 10 and greater than 1. So we want to move the decimal point that's here at the end so that it's in place in this number somewhere so that we have a number that's greater than 1 but less than 10. So if I move it to the left, I'm going to be getting a number that is going to be getting smaller than what it is. So I'm going to keep moving it until I get a number. Now I have 386. That's not less than 10. Now I have 38. That's not less than 10. Now I have 3.86. That is less than 10. So I have 3.86. That is less than 10. And I'm going to multiply it by 10 to some power. The power is going to be however many times I moved my decimal. So let's see. I'm going to count my zeros in groups of 3. So here I moved it 3. And then I moved it 6, and then I moved it 9, and then I only moved it 2 more, so 9, 10, 11 place values. So this is going to be 3.86 times 10 to the 11th. And why this works is because if we think about it, we have the number 7, and if we multiply 7 times 100, we get 700. So really we're just taking the decimal point here that's behind the 7 and we moved it 2 places to the right and we added 2 zeros. So if we have 100, we can write 100 as 10 to the power of 2. That equals 100. So that is why we can write this as 10 to the power of 11. So let's try some more examples. So let's say we have this number. So we want to move our decimal point from the very end here to be between the 7 and the 5, because 7.5 will be less than 10 but greater than 1. So we would have 7.5 times 10, and we need to know how many decimal places we're moving. So if I'm moving from here, that's a group of 3. That was 3 decimal places, 6 decimal places, 9 decimal places, 15, 18, and 1 gives me 19 decimal places. So the reason we're writing these numbers in scientific notation is because, well, I'm not really sure how to read this number. Like, I know that this 0 here is in the thousands place value. I know that this is millions, billions, trillions, and then beyond that, I really had to look up my place values last night. This is quadrillion, and then beyond that, it's quintillion. So I wasn't really sure how to read this number, and I'm sure you weren't really sure how to read this number. So we do know how, though, to read this. We would say it's 7 5/10 times 10 to the 19th power. That's much easier to read. So let's also look at some negative exponents. So if we have 10 to the negative 1, that means we have 1/10. Or 0.1. Okay, notice it didn't give me a negative number, it just gave me a decimal value. So if I had 10 to the negative 2 power, that would give me 1/100th, or 0.01. So when we have scientific notation, and we would have 7.33 times 10 to the negative 4th power, that would mean we would have a smaller number than 7.33, not a larger number. So that means we would have to move our decimal point not to the right to make it a larger number, but to the left. So 1, 2, 3, 4 to the left. So we would have to add 3 zeros. 1, 2, 3, and we would have this number. Now this is the tenths, hundredths, thousandths, 10,000ths, 100,000ths, and this is the millionths. So I do know how to read this number. However, when we get into the smaller numbers, it's much harder to read them. So if we have smaller numbers like, that's a decimal point, I would really have no idea how to read this number. And we get into these very small numbers when we're talking about possibly bacteria or things like that in science class. So how would we write this number in scientific notation? Well, we would take the decimal point here at the end, and we would move it so that we would have a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would have 9.3 times 10 to the negative 9th power, because it was a decimal. And we want to make this number into a decimal, so it's going to be a negative exponent. Okay, let's try a couple examples. Alright, let's change, or you try this one. Go ahead and hit pause and try this example. Change it into scientific notation. Alright, well this is where you should have started. You should have 7.22 times 10 to the, what did you get? Let's see. We have 3, 6, 9, and then 9, 10, 11th power. So you should have gotten 7.22 times 10 to the 11th power. Let's try another example. Go ahead and hit pause and try this example. Alright, you should have 8.1 times 10 to the, let's see, we have 3, 6, 9, 12, and then 13 14th power. Hopefully that's what you got. Let's try another example. Let's try a decimal this time. Change this number into scientific notation. You should have 3.1 times 10 to the, how many jumps was that? That was 8. Remember, it's a decimal, so it's negative 8. Alright, well that's it for scientific notation. Practice this on your worksheet. If you need more practice, go back in the video and rewatch some of the examples.